Welcome guys to this tutorial session. So in this video we are going to solve question 24 of tutorial sheet 3. So what you should do before you start watching this video, just subscribe, like the video and share to your friends. Also remember to put the challenging question numbers of this tutorial sheet, those questions which are challenging you. Comment, leave them in the comment section so that I may help you. So this one, how you go about this one is like, you have this function, f of x is equal to ax plus b, that's if x is less than 0, and 2 sine x plus 3 cos x when x is greater than or equal to 0. So solving this question, we'll do this. First, let us find the limit. As you know, for a limit to exist, limit as x approaches a certain constant from the right of a certain function should equal the limit as x approaches a constant from the left of the same function. So we'll go by solving this like this. Okay, let's say limit as x approaches 0 from the left. So when you're approaching 0 from the left, which means x is less than 0, right? So in this case you go with the first function there. So we do this plus b. So like this you can substitute, where there is x you put 0 plus b, which means this limit equals b. Let us proceed. Let's proceed. We find the limit. So let me use the different color. Let me use a different color. So limit as x approaches 0 from the right, which means here x is greater than or equal to 0, a positive number. So there you go with the second function, 2 sine x plus 3 cos x. So there just go direct and substitute your 0 where there is x. You have sine 0 plus 3 cos 0. By doing this, you have something like this. Sine 0 is basically 0 plus 3 cos 0 is 1. So your answer is 3. That's your right limit. Let us proceed. So following this rule here, following this rule here, this rule, you say for existence, the limit as x approaches c from the right of a function should equal the limit as x approaches a constant of the same function. So in this case, we can equate b will equal 3 because the right limit is giving us 3 and the left limit is giving us b. So it means b equals 3. Let us proceed. Now it's saying we should find the value of a. Finding the value of a will do this. We are going to differentiate this function from the right and the left. So this is the left derivative. So the left derivative, when it's differentiable at the point 0 where x is equal to 0. So we use the first principle, which says limit as h approaches 0 of f of x plus h minus f of x over h. So in this case, it's differentiable at 0. So this sign here simply means it's a left derivative. Don't be confused. Of f of 0, where there is x, you put 0, minus f of 0 over h. So we will consider the left function, which is saying this ax plus b. So here, excuse me, let me just add another page. All right, we continue. So in this case, where there is x, you are going to put 0. So you'll find that solving this, you are going to have something like this. You're going to have something like this: h minus b, when there is 0 here, over, okay, let me just write down like this, is equal to the limit as h approaches 0 of a 0 plus h minus s plus b minus the function here 0 plus h. Okay, let me just rub. I think I don't have enough space. Okay, this will be like this. A, where there is, I also rub this so that you may not be confused. So following this function, you're going to write like this: limit as h approaches 0. It's the same as the differentiation of this, so don't be confused. That's a, where there is x, you put 0 plus h minus the function, so plus b minus the function we have is this one, a, but there you are going to put 0 where there is x over h. So solving this, you will do something like this. That will be ah plus b, plus b, that's a b plus b, like this, over h. So limit as h approaches 0, you have ah plus 2b over h. Solving this, can say limit as h approaches 0 of ah over h plus 2b over h. So when h approaches 0, this and this will cancel. You're going to remain with a plus 0 here, which means the left derivative of 0 is equal to a, like this. So let us proceed to the right derivative. To the right derivative, the right function we have is 2 sine x plus 3 cos x. So f prime means the derivative of f at x, which is equal to the limit as h approaches 0 of this 0 plus h minus f at 0 over h. So let us proceed. Limit as h approaches 0 is equal to 2 sine, so 0 plus h simply h. You put h here where there is x plus 3 cos h. Now when you put 0 regarding this function here, you find that you are going to have 3 here when you put 0. So it's minus 3 over h. So let us do something to this equation. You can rewrite this like this: 2 sine h over h plus 3 cos h minus 1 over h. Now, according to the rules we have here, in mathematics you follow the rules. So following the rules, sine theta over theta, when the limit, when theta approaches 0, this is equal to 1. And cos theta minus 1 over theta, when the limit as theta approaches 0, this is equal to 0. So let us consider this. Let's consider this here. So in this case, you see that this is 2. Here is 1. Following this rule, it is 1 plus 0. So the derivative, the right derivative at 0 is equal to 2. So going back to our rule, like the way I introduced you to this question, I said the limit as x approaches a certain constant of the function should be equal from the left and from the right. From the right. So even the left derivative at 0 should equal the right derivative at 0. So which means a will equal 2. So this is how you can find the values of a and b when you are given this kind of equation. So don't forget to subscribe, share, like the video, and also comment in the comment section there. Tell me the questions that are challenging you. Just leave a question number. We are solving tutorial sheet 3, MSM 112.